So now we're going to be talking about factoring polynomials with a leading coefficient greater than 1. I think I just misspelled coefficient. Yeah, I think that's only supposed to have one F. Oh well. I am a math teacher. I am not an English teacher. Well, yes, I will apologize because I have respect words. So here's the thing. When we're doing this, we're going to see some similar processes to what we've done before. Now, there's a lot of different ways of factoring polynomials with a leading coefficient greater than 1. The one that I want you to stay away from is what we call guess and check. Guess and check is about as effective as it sounds. It basically means that you're going to come up with all possible combinations of factors and then just check them all. And on some polynomials, you might end up with 10, 20. I've actually seen things that would have up to like 300 permutations. So it's not necessarily our best way of going. So here's what we're going to do. Let's say we've got something like, let's say I've got 3x squared minus 10x plus 8. Actually, I'm going to make this a plus 10x because I want to keep our signs simple to start with. Now with this, what we're doing is we're going to be doing a process that's called AC factoring. And what this comes from is our coefficients. We're going to call these A, B, and C. So we're going to be we're going to use all three of these, but our key number is A times C. So this is our first thing that we need to keep in mind. Our key number is A times C. So here, this is going to be 3 times 8. So 3 times 8 is 24. And just like some of our previous processes, we take that key number and we're going to find that factor pair that adds to our middle coefficient. So we're still going to list our factor pairs. And we're going to choose the pair that add to B, that middle coefficient B. After that, it's going to be a little bit different. So here, this is positive, so both of my factors would either be positive or negative. In this case, they're both going to be positive. So I'll go through 1 and 24. Nope. 2 and 12. Nope. This would work if this were negative. I could do that, but that's not going to be it. 3 and 8 would add up to be 11. Or 4 times 6. Hey, there we do. There we have it. This is where things are going to start looking different, because what we're going to do is, instead of just filling in our binomials, we're going to use this factor pair, or use these factors to split the middle term. And then once we're done doing that, we're going to do factor by grouping. Not by grouping, grouping, O-U-P-I-N-G. I can spell today. It is also appropriate to properly caffeinate your instructor. Okay, so here's what we mean by split our middle term. This 10x, I could rewrite that as 4x plus 6x. So if I were to add this back together, I would be right back where we started. Of course, that would be a step backwards. So when we're factoring by grouping, here's what we're going to do. We're going to do greatest common factor factoring on the first two terms. we're going to do greatest common factor factoring on the last two terms. And then we're going to factor out the common binomial. When I say factor out, it's still going to be there. It's just going to be in a different order. So this is literally what factor by grouping is. So let's show you what this looks like. So in this my first two terms, I look at this and I say, oh, well, what do these two have in common? And I'm essentially ignoring that 6x plus 8. So I don't have a number that goes into both 3x squared and 4x, but I do have an x that's common to them. So I'll factor that x out. So that's going to be x times 3x plus 4. And I will say, always include this middle sign, whatever that is. We're going to factor that. That's going to be part of our process. And it looks like what goes into both 6x and 8 is a 2. So I am essentially dividing both of these things. I hope you realize that when we factor this out, we're essentially doing a kind of a specialized type of division. And I hope also that you've noticed that we have this binomial here that's in common to both of these. And a common factor doesn't have to be just a number or a variable. It could be an entire binomial. So what we're doing is we are just factoring out that 3x plus 4 from both of these terms, and we'll be left with x plus 2. And that's our answer. We're done. So that's a good example. So we had a pretty good example of that one. Now I'd like to show you some other examples, and here I want you to pay special attention to the signs, because the signs are kind of what can be, they can mess you up if you're not quite sure what you're looking for. So here is what we're going to do. We're going to do, let's see. Let's say we've got 3y squared minus, let's see here, I'm going to do minus, coming up with examples on the fly, I shouldn't do that. I'll do minus 23y and then plus 20. Now this is, here what we're doing is our process is going to stay the same. My key number is going to be this first number times the last one. So 3 times 20 is 60. So this is positive, and I need to find something that's going to add together to be a negative. So instead of both of my factors being positive, both of them are going to be negative this time. Negative 1 times negative 60, that adds up to be negative 61, but it multiplies to be 60. 2 times 30, that adds up to be 32. 3 times 20, and in fact, this actually does the trick. This would multiply together to be 60, would add together to be negative 23. So we're going to split our middle term. So here we still have our 3y squared, but this is going to now turn into minus 3y minus 20y, and then plus 20. Now, in these first two, I'm going to factor out I'm going to do my greatest common factor. So I've got 3y squared and 3y. It looks like 3 and y go into both of those, and that's going to leave me with y minus 1. So even though I've had some folks say, wait, you're factoring out a 3 minus an entire 3y. Where is this term coming from? Well, remember, if I were to multiply out, I should end up with the line I have above. Now, I said this once before, always include this sign. So what I'm going to do here is I'm going to factor out a negative, and in this case, I'm going to factor out a negative 20. So what's happening, anytime I factor out a negative number, the signs inside the set of parentheses change. So instead of being a negative term first here, this is going to be a positive y. Instead of a positive 1, this is going to become a negative 1. And there we have it. So note that if I were to multiply this out, negative 20 times y would be negative 20y. Negative 20 times negative 1 would be a positive 20. So our signs work out there. And now we're going to just factor out our common binomial. We've got y minus 1 times 3y minus 20. And we're done. Cool. Let's do it again. And I'll come back to this. So, well, actually, I'll leave that there. Let's do another example. This time I'm going to do, let's see. I'm going to do 8x squared minus 2x minus 3. So here I've got this, my key number is going to be 8 times negative 3, so that's going to be negative 24. So because this is negative, I've got one sign that's positive, one sign that's negative. And it looks like my larger one is going to be negative. So I'll do 1 and negative 24. That doesn't do it. 2 and negative 12. That doesn't do it. 3 and negative 8. That would be negative 5. We're getting closer. 4 and negative 6. And this factor pair does the trick. 4 times negative 6 multiplies to be negative 24. 4 minus 6 adds to be negative 2. So we're going to split our middle term here. 8x squared plus 4x minus 6x minus 3. Oops, 3. And what I'm going to do now is I'm going to factor out my greatest common factor. First two terms, I'll take out that 4x. That'll leave me with 2x plus 1. I always include this middle sign, and it looks like what goes into both 6 and 3 is going to be a 3. And that'll leave me with 2x plus 1. So remember, when we factor out a negative, both these signs change. Now we'll factor out that common binomial, that 2x plus 1. And here we've got our 4x minus 3. And we're done. Okay. There's a couple other ways of going through this. I also want to remind you, if you're not entirely certain of your answer, you can always check by multiplying. So if I were to multiply this 2x plus 1 times 4x minus 3, let's FOIL that out. 2x times 4x would be 8x squared. 2x times minus 3 would be minus 6x. 1 times 4x is plus 4x. 1 times minus 3 is minus 3. And sure enough, we've got 8x squared minus 2x minus 3, which is exactly what we started with, so our answer checks out.